Good morning, students. I am Munsi Rashidul Islam, Assistant Professor of Department of Mechanical Engineering, JS College of Engineering. Now, today, I am going to present a new lesson. That lesson is actually the design of cone and centrifugal clutch. Cone and centrifugal clutch. That means that is actually the third lesson of this topic. Third lesson of this topic means that is actually the under the section of clutch. So class section, that is actually third class. So for that point of view, we have to first class we have just discussed the overview of the clutches. Overview of the clutches means the what is clutch, how many types of clutch, where the clutch are engaged or disengaged position, what are the different material properly used in clutch position, etc., etc. Or in second class of clutch topic, that will cover means that already covered in the design of single plate clutch and multiple clutch. And today is the third class. Third class means design of cone clutch and centrifugal clutch. So first of all, we can introduce the cone clutch and the different shape of the centrifugal clutch. So first of all, we have to concentrate the single plate clutch, how it can behave in just like a different mode of operation. So if you see the figure, that figure means of cover assembly of single plate clutch. In cover assembly of single plate clutch, if you see that figure, so there are lot of parts are there. That parts are directly engaged or indirectly engaged to the clutch design. So first, number one point, that point is actually cover. So in automobile vehicles or any type of vehicle system where the clutch should be employed or should be engaged, so that portion obviously are in covered shape. So the in this figure, one is actually cover and two indicating point, that is actually release lever. Release lever, that is actually two, and that shape is just like a one half-handed type shape. So that is actually the release lever. Third point is anti-rattle spring. So that means here the two types of spring we can use in the attachment of the clutch. So number one is helical compression spring, and number two is rattle anti-rattle spring. Now next point is four point, that is actually pressure plate. Plate means the all the plates that I used for design of the single plate clutch. The plates are in under pressure, and that pressure may be in uniform pressure or non-uniform pressure. So most of the cases we can use the uniform loop pressure distribution. So that from that point of view, the pressure plate are in pressure. Next, point number five, thrust spring. Thrust spring, that also we used as a helical compression spring. Thrust spring, that is basically one type of helical compression spring. Now, say point number six, release lever plate. Release lever plate, it is actually the lowermost portion of the total single plate clutch design. So that portion is actually carry the total load of the clutch weight also. That can obviously with high strength and obviously the high toughness. Next is eye bolt, point number seven. Eye bolt, that is actually used to hold the two different parts with different shape of the figure. Now next is eye bolt knot. Obviously knot classification and knot definition is actually used where the bolt are there. So nut and bolt are in connected with some eye bolt type. So for that reason, eye bolt and nut both are engaged in some same criteria or same point of view. Next, plate retainer or release lever, and number 10 point is actually the release lever pin. That pin is used to separate the both the parts means when the all the parts are in assemble conditions, we can easily separate each and every part by the application of this release lever pin. That is actually the fundamental classifications of single plate clutch, and that is actually the simple mechanism of single plate clutch. If you are not covered the single plate clutch design, we cannot and go through the multiple clutch design or cone clutch design or any type of centrifugal clutch design. So for that's why we first covered the basic idea of single plate clutch, and let's the multiple clutch. And that is actually the types of friction material. So as we know that as we know that as we know that the design of single plate clutch. So for that case it is actually under the friction clutch. So for that's why, so material properties or friction material properties must have to be there. So for that reason, the friction material behavior is most important, and that is actually the different mode of friction material that can I use for the design purpose. So for fast cases, we can use the millboard type. Millboard type means that is actually the one special type of friction material. That material mainly contains asbestos sheet that is actually treated with certain impregnants. So that is special type of friction material, and mostly use this type of material for the design purpose of single plate clutch. So plate or disc that can I use for design of single plate clutch without any type of material friction material behavior is not supported for the material composition. So we cannot go to the right design proportion of any type of single plate clutch. So that is actually in the properties of single material, properties of friction material of different modes. Now next, molded type. Molded type means obviously that also be another type of friction material that is actually mixed asbestos fiber, and it is basically in the standard proportion of mixed mixed mixed. That means, sorry, some yeah. Now mixed asbestos fiber with binding material. Binding material means suppose mixed asbestos type with binding material, some composition or some binding reagent can be used as a mixture of this type of friction material. That is actually molded type material. Next, oven type. Oven type, that is actually the cloths with certain binders is actually used to compact the total situation of the whole material composition. Now next is solid oven variety. That is actually cloth is oven to required thickness. And next one is laminated variety. Laminated variety means layer of cloth one upon the other, and that are held together by a binder. Stitches are provided in addition to the binder. Stitches means suppose some stitch is required to binding the whole parts by the binder, so some stitches should be required. So for that cases, we can use some stitches to provide the additional binding conditions. Now next point is single plate clutch design. Single plate clutch design, and obviously there are in the single plate clutch design we can follow the two types of theory. That means suppose some torque can be transmitted or power can be transmitted from one shaft to another shaft. We can we can consider the two theory. That two theory is very important to calculate or to design the any type of single plate clutch. So for that cases we can use two theory. One is uniform pressure theory and another is uniform wear theory. Uniform pressure theory, that means the pressure is uniformly distributed over the entire surface of the over the entire surface of the disc or plate. So over the entire surface of the disc means the pressure means that means intensity of pressure small p. That intensity of pressure is equally distributed or uniformly distributed over the entire surface of the uh, plate disc or plate surface area or disc area, and total uniform pressure will be constant. That means p is equal to constant. So so as per the empirical as per the mathematical conditions, so we can write total axial load on clutch. Total axial load on the clutch, that is actually w is equal to n into p r. P means total pressure and r means the radius of the disc. So pr ro square minus ri square means outer radius square minus inner radius square. Now next point is total torque transmitted. We know that now torque is actually load into distance or load into any type of distance. That may be vertical distance, that may be horizontal distance, that may be vertical or horizontal. So total torque transmitted, that is actually capital T, that is equal to two-third of mu. Where mu, how it can be, it can here mu. So mu is actually coefficient of friction. So two-third of mu. W is total axial load. RO R0 RO cube minus RI cube whole by RO square minus RI square. So T is equal to means total applying torque. Total applying torque means total generated torque. That T is equal to mu into W into R. Here, here capital R is equal to effective mean radius. Here capital R is equal to effective mean radius. That means R is equal to two-third of RO cube minus RI cube whole by RO square minus RI square. That is the actually case of the uniform pressure theory. That means total pressure will be constant. Next, uniform wear theory. In uniform wear theory, total wear, total wear means total intensity of pressure into distance will be constant. That means if r is decrease, intensity of pressure will increase. That means r is increased and intensity of pressure is decreased means p is inversely proportional to radius. So p is inversely proportional to the radius. So for that's why the total axial load on the clutch, total axial load on the clutch, that will be w is equal to 2 pi 2 pi pr. Here pr is one product, that product is actually constant product. So pr, ro minus ri, r outer radius minus inner radius. Now torque transmitted total torque transmitted, T is equal to mu into W, RO plus RI by 2, RO plus RI by 2. That means mean radius, effective mean radius. So for that cases, effective mean radius capital R, that will be RO minus RI by 2, and just RO plus RI by 2 is replaced by capital R. So total equation will be T is equal to 2 mu W into R. That is actually case of uniform wear theory. So to theory that I already explained just few seconds ago. So in these two theory is applicable for all the cases of the design of single plate clutch, multiple clutch, cone clutch, and centrifugal clutch. So these two theories is very important for the design of any type of clutch. So for first cases in your semester examination, that two theory for each and every point of the design of clutch, first of all you have to explain this theory is applicable, which theory is applicable for that time, for this point of design. So uniform pressure theory or uniform wear theory. So if you are not clearly describe the which theory is applicable for that particular problem, you cannot solve the problem with proper guideline. But obviously if any problem, no theories will be considered. So for that cases you have to consider both the theories, either in both the theories, or in either in uniform theory or wear theory. Now this is the typical figure, one simple figure of multiple clutch. If you see in the single plate clutch and multiple clutch, here just left hand side of the just from the right hand side to left hand side, spigot end, actually the spot of middle section, that spigot end spot, the here are the three or four plates are engaged. Three or four plates are engaged means, that means more than two plates are there. So more than two plates are there means that clutch is actually behave just like a multiple clutch. So when the more than two plates are engaged in such a conditions, we can consider that the multiple disc clutch. But one question is there. In the equation of single plate clutch and multiple clutch, no difference will be there. Only one difference is there. In multiple clutch, number of pair of contacting surface will be multiplied with the equation of single plate clutch. Otherwise, no difference will be there. So for that cases, we can consider that the total number of pair of contacting surface, that is included or that is multiplied with the single plate clutch, then we can easily solve on the design of multiple clutch. Now just I told few seconds ago, that is actually design details of multiple clutch. That means total n number of friction plates are there, and total n number of plates. That means if in driving shaft, if in driving shaft four number of plates are there, or in driven shaft five number of plates are there, so total number of pair of contacting surface obviously obviously 5 plus 4 minus 1, because because pair of contacting surface means obviously when the two plates are in contact position, otherwise it can be valueless or it can be meaningless. So pair of contacting surface means total number of discs in either in driven shaft or driving shaft, total number minus 1, that is actually pair of contacting surface. Now torque will be n minus 1, means total number of discs minus 1 into mu coefficient of friction, w obviously the total axial load, and r is the actually the radius. So so if I put the equation in uniform pressure theory and uniform wear theory, if I put the equation in uniform pressure theory and wear theory, total torque total torque in pressure theory will be n minus 1 into 2/3 of mu into w rho cube minus ri cube whole by rho square minus ri square. That is actually the case of single plate clutch, uh, multiple clutch for uniform pressure theory. Next, uniform wear theory, tu is equal to n minus 1 into w into ri plus rho by 2. That is the problem. That problem I can explain in this topic when I covered single plate clutch design and multiple clutch design. And clutch fishing. Clutch fishing means the clutch have some properties, good properties of the fishing conditions. So first one is some requirement is there. So requirement of a good clutch fishing. First one is good wearing properties. Number one. So clutch have a good wearing properties. Number two, presence of good binders in it. Presence of good binders in it. So that is actually the case of the good binder case binder, which is actually used for the clutch design. Now point number three, cheap and easy to manufacture. Obviously, the costing material should be considered. Otherwise, if costing is too much, it cannot be designed perfectly. As the costing should be calculation for the design of any product or any topic of any material composition, material properties, material combination, mixing conditions, etc., etc., should be considered for the manufacturer. High coefficient of friction. So obviously, clutch material should be high coefficient of friction. Otherwise, it cannot be transmit more torque rather than the other design of cone and centrifugal clutch. And next is high resistance to heat. So obviously last point is very important, because resistance should be high, because it can friction, it can sustain on the frictional behavior of material, so resistance should be high. Now, next is common clutch facing material. So, common clutch facing material means there are a lot of materials that can used for design of clutches. So, first material is leather. Leather, and that coefficient of friction should be 0. 0.27, and second one is cork 0.32, fabric fabric is obviously zero point 0.4, asbestos 0.2, ray asbestos and ferrodo 0.35, non-asbestos with clutch facing, that also be considered as a smooth clutch material. Now next point is cone clutch. Now in cone clutch, if you see the figure, in cone clutch no hesitation will be there, because the this name behave just like a cone, and that shape of the cone will just like a frustrum of the figure. So if you see the figure of the left hand side, when the W load will applied, means driven shaft is applied, so in some certain angle will create to the lowermost portion of the driving shaft. That means in the total transmission point, total applying friction lining will be in inclined shape, and that inclined shape is actually to the horizontal. That angle create is alpha. That alpha is known as the alpha is known as the cone angle. But in your problem, alpha is considered as a semi-cone angle, because upper portion obviously alpha, and lower portion obviously another alpha, so alpha plus alpha 2 alpha, that 2 alpha is known as a cone angle, and alpha is known as semi-cone angle. So only one pair of driving surfaces is possible. Only one pair of driving surfaces is possible. That's why the total number of contacting surfaces is actually one, and that contacting surface means the inclined surface of the driving shaft portion body. That portion body in that particular area, the total distribution of the pressure, that pressure may be uniform pressure theory and maybe uniform wear theory. So uniform pressure theory and wear theory, both the theories is applicable for this type of design of cone clutch, and that's why this type of clutch is mostly used for the automobile vehicles or any type of vehicle, and there's that's design is perfect rather than the compact, and perfect rather than single plate clutch and multiple clutch. And it is actually this type of design is mostly used for heavy vehicles now. So total torque, as it create some certain angle, so for that cases total torque transmitted, that will be capital T is equal to mu into W into Rm. Rm means mean radius into cosec alpha. Cosec alpha means cosec alpha. So for that cases, maximum torque transmitting capacity or maximum torque transmitted, capital T is equal to mu into W Rm cosec alpha. Now that is actually a one pictorial view of this figure. And just pictorial view means if I see the cylinder, and you have to consider the total say, radius. Mean radius means in the friction lining area, and elemental ring area, that radius is R, and inner radius and outer radius also be counted. And as per the conditions, if I see the left hand side figure, the total angle and created angle should be alpha plus alpha 2 alpha, that I already mentioned. So total alpha total cone angle is 2 alpha, and semi cone angle is alpha, and total normal intensity of pressure, that is equal to Pn. And so total pressure distribution in uniform pressure theory as well as a uniform wear theory that I already counted, and that is actually the case of the total design of cone clutch. And that's all for the today's class, and next class we can discuss in another topic, new topic for the design of upcoming session. So thank you for today's lesson.